we have to prove out of one and only out of n, n+4, n+8, n+12 or n+16 is divisible by 5. For that, by Euclid's division algorithm, we know that any positive integer can be expressed in the form 5q, 5q plus 1, 5q plus 2, 5q plus 3 or 5q plus 4. So by Euclid's division algorithm, any positive integer can be expressed in the form 5q, 5q plus 1, 5q plus 2, 5q plus 3 or 5q plus 4. Case 1. The case 1 n is equal to 5q. When n equal to 5q, we are going to substitute n equal to 5q in n, n+4, n+8, n+12 and n+16. First n is equal to 5q. So it is exactly divisible by 5. Next n+4. n+4 is substitute n is equal to 5q. So 5q plus 4. The remainder is 5. So not divisible by 5. Next n+8. n is 5q. So 5q plus 8. This 8 can be written as 5 plus 3. So 5q plus 5 plus 3. Now taking 5 common from these two, we will get 5 into q plus 1 plus 3. So here remainder is 3. So not divisible by 5. Next case n+12. Substitute n is equal to 5q plus 12. So this 12 can be written as 10 plus 2. Now taking 5 from these two, you will get 5 into q plus 2 plus 2. So here remainder is 2. So not divisible by 5. Next n+16. Substitute n is equal to 5q plus 16. So this 16 can be written as 15 plus 1. Now taking 5 from these two. So 5 into q plus 3 plus 1. So here remainder is 1. So not divisible by 5. So out of these n, n+4, n+8, n+12 and n+16, only 1 is divisible by 5. Now case 2. n is equal to 5q plus 1. So substitute n is equal to 5q plus 1. Here remainder is 1. So not divisible by 5. Next n+4. Substitute n is equal to 5q plus 1 plus 4. So it becomes 5q plus 5. Now taking 5 common. So 5 into plus 1. That means it is exactly divisible by 5. Now next n+8. Substitute n is equal to 5q plus 1 plus this 8. So it becomes 5q plus 9. So this 9 can be written as 5 plus 4. So 5q plus 5 plus 4. Taking 5 common. So 5 into q plus 1 plus 4. See remainder is 4. So not divisible by 5. Next n+12. Substitute n is equal to 5q plus 1 plus 12. 12 plus 1 is 13. So this 13 can be written as 10 plus 3. Now take common from these two. 5 into q plus 2 plus 3. So here remainder is 3. So not divisible by 5. Next n+16. Substitute n is equal to 5q plus 1 plus 16. So 16 plus 1 is 17. So this 17 can be written as 15 plus 2. So 5q plus 15 plus 2. Now taking 5 common. 5 into q plus 3 plus 2. So here remainder is 2. So not divisible by 5. So out of these n, n+4, n+8, n+12 and n+16, only n+4 is divisible by 5. Next case, when n is equal to 5q plus 2. So as usual, n is equal to substituting n is equal to 5q plus 2. Here remainder is 2. So not divisible by 5. Next n+4. So n is 5q plus 2 plus 4. So 2 plus 4 is 6. This 6 can be written as 5 plus 1. So taking 5 common. So 5 into q plus 1 plus 1. So remainder is 1. So not divisible by 5. Next n+8. So n is 5q plus 2 plus 8. Now 2 plus 8 is 10. Now taking 5 common from this. 5 into q plus 2. Here no remainder. That means it is exactly divisible by 5. Next n+12. Substitute n is equal to 5 cube plus 2 plus 12. So this becomes 5 cube plus 14. So this 14 can be written as 10 plus 4. Now taking 5 from common from these two. So 5 into cube plus 2 plus 4. Here remainder is 4. That means not divisible by 5. Next n plus 16. N is equal to 5 cube plus 2 plus 16. So 16 plus 2 is 18. Now 18 can be written as 15 plus 3. So we have to write in terms multiples of 5. So 5 cube plus 15. Take 5 common. 5 into cube plus 3 plus 3. So a remainder is 3. So not divisible by 5. So out of these, only n plus 8 is exactly divisible by 5. Others are not divisible by 5. Next case, n is equal to 5 cube plus 3. Substituting n is equal to 5 cube plus 3. So here remainder is 3. So not divisible by 5. Next n plus 4. N is 5 cube plus 3 plus 4. 3 plus 4 is 7. So this 7 can be written as 5 cube plus 5 plus 2. So 5 into cube plus 1 plus 2. So here remainder is 2 not divisible by 5. Next n plus 8. So 5 cube plus 3 plus 8 is 5 cube plus 11. This 11 can be written as 10 plus 1. So taking 5 common. 5 into cube plus 2 plus 1. So a remainder is 1. So not divisible by 5. Next is n plus 12. So n is 5 cube plus 3 plus 12. 12 plus 3 is 15. Now taking 5 common. So 5 into cube plus 3. Here no remainder. So this is exactly divisible by 5. Next n plus 16. N is 5 cube plus 3 plus 16. 16 plus 3 is 19. This 19 can be written as 15 plus 4. Now taking 5 common. So 5 into cube plus 3 plus 4. So a remainder is 4. So it is not divisible by 5. So out of these, only n plus 12 is exactly divisible by 5. So next case, when n is equal to 5 cube plus 4. So substituting n is equal to 5 cube plus 4. A remainder is 4. So not divisible by 5. Next n plus 4. N is 5 cube plus 4 plus 4. So this becomes 5 cube plus 8. This 8 can be written as 5 plus 3. Now taking 5 common. So 5 into cube plus 1 plus 3. A remainder is 3. So not divisible by 5. So next n plus 8. N is 5 cube plus 4 plus 8. So 8 plus 4 is 12. Now this 12 can be written as 10 plus 2. Now taking 5 common. 5 into cube plus 2 plus 2. So a remainder is 2. So not divisible by 5. Next n plus 12. So n is 5 cube plus 4 plus 12. So 5 cube plus 16. This 16 can be written as 15 plus 1. Now taking 5 common. So 5 into cube plus 3 plus 1. So not divisible by 5. So next is n plus 16. N is equal to 5 cube plus 4 plus 16. 16 plus 4 is 20. Now taking 5 common. So 5 into cube plus 4. Here no remainder. So this is exactly divisible by 5. So out of these n plus 4, n plus 8, n plus 12 and n plus 16, only n plus 16 is divisible by 5. So that's we have to prove. I hope you understand this problem.